In today's lesson, we will be graphing solutions of inequalities. The first thing that we're going to do is we're going to review all of the different signs or symbols that we can use when we are writing an inequality. This first sign, underlined in green, would be the greater than sign. Here, if we were to write a statement, it would say, 7 is greater than 6. The second symbol here would be the less than symbol, and you can see it kind of has the shape of an L. And if we were to write a statement to describe this inequality, we would say, 6 is less than 7. The third symbol that we could use, underlined in green here, is less than or equal to. If we were to write this inequality as a statement, we would say, any number less than or equal to 5. Our fourth symbol would be greater than or equal to. And if we were to write a statement for this inequality, we would say any number greater than or equal to 12. Our last inequality symbol is an equal sign with a slash through it, and this means not equal to. If I were to write a sentence to describe this last inequality, I would write the sum of any number in 2 as long as it is not equal to 3. So now that we have reviewed those symbols, we are going to go ahead and figure out how are we going to graph these solutions, or take a solution set and graph it. In order to graph an inequality, we're going to need a few different things. The first thing we're going to need is an inequality that has a variable in it. 2, we're going to have to solve that inequality to find the solution set or the solution to the inequality. And 3, we are going to need a number line to put our solution on when we graph it. In our first example here, we are looking at x is greater than 3. Now, we can look at this problem and we can decide, okay, well, what numbers actually would work for this inequality? We could sit here and we could list a few. Well, does 3 work? No, because 3 is not greater than 3. 3, okay, is not greater than 3. This would not work. But if we were to go any number bigger than that, okay, so is 4, okay, so we're substituting in 4 for where x would be. Is 4 greater than 3? Yes. Okay, is 5 greater than 3? Yes. So any number that is bigger than 3 is going to be a solution to this inequality. Then we would go ahead and we would try to write our solution set. Well, our solution set would include any number that's bigger than 3. We don't include 3. So a solution set equal to, we draw our bracket, and then we would write any number. We're going to write this as a sentence. Any number, so anytime there's a variable, we can represent this. This is just taking the place of a number, right? So that is why we write any number to represent that variable. It's a good phrase to use when we are trying to write a solution to an inequality with a variable in it. Any number, then we just go across, greater than, because we don't want less than, 3. Finish it with our bracket. Now we have to think about, okay, how do I graph this? Well, if you think about the steps that I talked about before we began this example, I said that we need a number line. So let's go ahead and draw a number line. We don't need to go less than 0 because we're not looking for small numbers. We're looking for numbers that are bigger than 3. So let's just go ahead and list them out. And I'm going to take a quick moment to just go over 2 different things when we are graphing an inequality. This is one of the most asked questions by any student. Whether I should have an open dot or a closed dot. So we'll focus on the open dot. We would use this when we have a greater than or less than symbol in our inequality. And this would just tell us that our number that is in our inequality, or where we place this open dot, that number is not included in our solution to our problem. Now talking about the closed dot. This is used when we have a greater than or equal to symbol or a less than or equal to symbol, and this means that the number that is in our inequality, or where we place this closed dot, that that number is included in our solution. So if we look back at our inequality, we can see that we are using a greater than symbol. Any number greater than 3 was our solution. So we are going to use an open dot here because of this reason. So when we come down to graphing our actual solution, so any number greater than 3, we're going to find 3 on our number line, and we are going to put an open dot there because we are not including 3 in our solution. We said that earlier up here. We said that our answer could not be equal to 3 because 3 is not greater than 3. So we put an open dot, and then we want all of the numbers that are bigger than 3. So we would draw an arrow going out to the right-hand side, and I could keep listing numbers forever that are bigger than 3. So we are just going to draw an arrow pointing to the right-hand side here. So this means that we are including every number up to 3, but not including it. And that is how you would graph a solution to x is greater than 3. We have an open dot, an arrow going to the right-hand side to show that we want every number or any number that is greater than 3. This is how you graph it. In our second example, we are going to be taking a look at y is less than or equal to 15. So if we were to write a solution to this, we don't have to do anything to solve it. It's already solved for us. We just need to write it in a sentence. So our solution set would be any number. Remember that a variable is replaced with the words any number less than or equal to, remember that's what that line underneath of there means, less than, I'm going to run out of room, less than or equal to 15. And that would be the solution to this inequality. Now we're going to worry about graphing it. So here's the number line that I've created to graph my solution to this inequality. A good rule of thumb is to look at the number that's in our inequality, place that onto our number line, and then put some numbers below it and some numbers above it. That way that either way that this graph has to go, you'll be able to graph it accurately. Now let's go back to our solution. We're looking for any number that is less than or equal to 15. I want to just reference back that we are going to use a closed dot in this inequality or to graph it because we have a less than or equal to symbol, and we would also use it with a greater than or equal to symbol. And what this means is that the number that is in our inequality is included in the solution. So we look back at our problem. Y is less than or equal to 15. Well, if we were to replace y with the number 15, we can write this out. Is 15 less than or equal to 15? The answer is yes. And that is why we are going to put a closed dot at the number 15 on our number line down here. So we're going to put a closed dot there. That means that 15 is included. It is an answer to our solution. Do we want numbers that are bigger than 15 or numbers that are smaller than 15 or less than 15? Well, if we look at our solution, any number less than or equal to 15. So we include 15, and we would want numbers that are smaller or getting smaller. And this would go on forever, even into negative numbers, but we're not going to worry about those right now. And we would just include an arrow showing that we would continue to include those smaller and smaller numbers in our solution. And that is how we would graph it. Closed dot, because we have a less than or equal to symbol, and we would start it at 15, and we would go all the way or include any number that is smaller than where we put that dot. So in our third example, we are going to look at an inequality that uses the not equal to symbol. In this case, we're using the variable z to represent that any number that is not equal to 8. We would go ahead then and write a solution set. Remember, we are just really writing out whatever these symbols actually mean. So basically we said any number, which is the z, not equal to, 8. So it's basically writing a sentence that describes these symbols. Now I have gone ahead and graphed the solution to this inequality. For some reason the video blanked out. Let's just go ahead and describe what we have drawn here. So 8 is equal to 8, right? Well, our inequality is any number that is not equal to 8. So we are going to put an open dot, meaning that 8 is not included in my solution, but every number up to 8 would be included, and every number after 8 would be included. And that is also why we have these arrows going to the left and to the right for this inequality, is because it doesn't matter if the number is smaller than 8 or bigger than 8, it just cannot be equal to 8. And that is how you would graph an inequality that uses the not equal to symbol.